Methods 2, Basic Skills, Revision Sheet 3. This is just going to be a quick set of answers going through the questions from this revision sheet. I'm going to make it available in PDF form in the comment section on YouTube and from my website, rawmaths.co.uk. So let's just run through these questions. Rounding to three significant figures. So, three significant figures. The first significant figure is the 1. Zeros do not count as significant figures if they're in front of numbers. Once you've started counting though, then you would count zeros. But this is the first significant figure, second, third. So I'm going to chop this number off at the 6. Check to see whether the 0 is bigger than 5 or 5. Then it would round up, but in this case it's not. So the answer is 0.0146. So those are our three significant figures. Highest common factor of 84 and 60. You have a calculator available to you on this test, so you can use it to work out what you think it is. But straight away I'm looking at 12s because I know 60 is in a 12 times table and 84 is in a 12 times table. I might just check to see if double that would work, 24, but it doesn't, so the answer is just 12. So the highest common factor. Right, 72 is a product of prime factors in index form. With 72 is a fairly small number, so if we think about it as, there's several ways of doing it. If we think about it as just 9 times 8, and then break down the 9 into 3 times 3, and the 8 into 2 times 2 times 2, a bit like a factor tree, then you'll have those numbers, they're all prime numbers, they multiply to give you 72. So in index form means with powers, so we're looking for 2 to the power of 3 times 3 squared. Now you could do this if it was a bigger number and you're not so clear what numbers go into it. You can do it just by repetitive division, starting with the smallest prime number. 2 goes into 72 is 36, 2 goes into 36, 18, 2 goes into 18, 9, and 9 is 3 goes into 9 3 times. So those are the prime factors around there. So that's another way of doing it. It's quite common. Finding the decrease from 780 to 725. What's the percentage decrease? Well, if we work out what percentage 725 is of 780, which was times that by 100, then that will tell us what percentage it is, and then we can work out the decrease. So 725 over 780 times by 100. Change that to a decimal, so that's 92.9487%. So the decrease is going to be 100 minus that answer, which is, so the decrease is going to be equal to 7.05, but 7% approximately. Find three consecutive prime numbers that add up to 83. Consecutive means one after the other. If we know our prime numbers, let's just whiz through a few prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, I think is the next one, 41. Now we want three consecutive prime numbers, so they're going to be about the same number. So if we just do 83 divided by 3, we get about 27. So we're looking for three numbers that are around about 27. So we've got 23, 29, 31. That's a possible combination. So there are three consecutive prime numbers. Let's just check they work. Which is 83. So those are our three. 23, 29 and 31. They add up to 83. Question 6, quite a tricky sort of a line ratio question. So if I've got a line and that's AB and M is in a ratio of 3 to 5, so there's our M, this is going to be 3 to 5, so that's going to be 3/8 of the line, that's going to be 5/8 of the line. N splits AB, so it's 3/4 of the way along the line, so from A to B, it's N is going to be 3/4 of the way along the line. so that's n. So this is 3/8, 5/8. So if we split this into eighths as well, so this is actually 6/8, and that is going to be 2/8, then we should be able to figure out on this line, this is going to be 2/8 of this bit. Yeah, so the 5/8 is all this. The 2/8 is this bit. We want to know what this bit is, what fraction is that, so that's 5/8 minus 2/8, which is 3/8. So our fraction in the middle there is 3/8 of the whole line. Okay, question 7. When you've got numbers in product of prime form, and you're actually trying to work out the lowest common multiple of a and b, you want the smallest number that both a and b go into. So you have to take the highest power of each of the prime numbers, because 2 squared, this needs to be 2 squared in the lowest common multiple, so that this 2 squared will go into it. And then we need to times that by 3 squared, because there's a 3 squared here. This has only got 3 to the power of 1. This is just 7, but this one's 7 squared, so I need to times by 7 squared, so that 7 squared will go into this number as well. So although I'm not overly interested in what this number is, I believe it's 1764, but that is the number. You always take the highest power of each of the prime numbers in the product of prime form. Okay, question 8. A bar of soap decreases by 12% each day. How much will 200 grams be left at the end of the week? So if it's decreasing by 12% each day, that means that it is... oops. Let's just move that. That means it's going down by 12%, so it's 100 minus 12%, which is 88%. And to work out 88%, we times by 0.88. We're starting off with 200 grams, so after 1 day, there'll be that times 0.88. After 2 days, it'll be times by 0.88 again, and then 3 days. So essentially, we're just timesing by 0.88 7 times. So we're timesing by 0.88 to the power of 7. So 200 times by 0.88 to the power of 7 equals 81.7 grams. Do 3 significant figures. Okay, we'll take the calculator in. That's what we actually need for the next one. This is a calculated question. It's just using the calculator, so we've got to type this into the calculator. We need to find a, which is all this stuff here. So let's put the fraction line in. The sine to the minus 1, which is shift sine. Then we've got cos. And then we've got 65. We need to close the bracket for the cos, close the bracket for the sine. Go to the bottom of the calculator of the fractions. We've got 3 lots of tan 45. Close that one, press equals, and it gives us 25 over 3, or which is in 3 significant figures 8.33. Okay, volume question, volume of a sphere. You don't need to know this formula, but you need to have it available. The volume of the sphere is 4/3 pi r cubed. R is 6 in this question, so we've got 4/3 times pi times 6 cubed. So 4 over 3 times shift pi. Oops, let's try that again. 4 over 3 shift pi times 6 cubed. That's equal to 288 pi. So that's the volume. So that, and if 1 centimetre cubed is worth £32, we just need to times that by 32. Times by 32 gives us 9,216 pi. Now we want it as money, so we need to change that into a decimal, which is equal to 28,952 pounds to the nearest pound, or you could go 92 to the nearest pence, but the nearest pound would be fine. Okay, question 11, expand and simplify. We've got two brackets here and we're subtracting. We've got to be very careful. As soon as we see this takeaway in this negative here, we've got to be careful with the signs in this. So let's just deal with the first bit. Sometimes it's better to do it a bit at a time. So 3 lots of 2 minus 3a. We've got 3 lots of 2, which is 6. 3 lots of minus 3a is minus 9a. And then we're going to take away 7 lots of a minus 1. Now I've got to be careful here. I'm going to put the takeaway there and treat it like a minus sign. So minus 7 times a is minus 7a, and minus 7 times minus 1 is plus 7. So then we've got to combine these two. We've got 6 plus 7 is 13, and minus 9a minus 7a is going to be minus 16a. Factorise this. This looks complicated, but it is only a single bracket factor. If we look at it written out in detail, so f times y plus f times y, you can see, hopefully, let's just use the marker pen, that there is a f in both and there is a y in both. And so our factor is f, y, and then what's left is going to be this y and this f. So we've got y plus f. So it's a single bracket with the factor is fy. Factorise 4a squared minus 16. I know when I did it in my class, we went to this. I'll do two versions. This factor where you do 4a squared is the same as 2a all squared, and 16 is the same as 4 squared, because that gives us the difference of 2 squares. You could factorise it just without this method, but the difference of 2 squares allows us to do this. We go 2a plus 4 times 2a minus 4. Now, that's strictly not actually accurate, because we can actually start by factorising out the 4 to start with. So if I take the 4 out before I even start, I'm left with that, and therefore difference of 2 squares there, where this is a squared minus 2 squared, would give me a plus 2 and a minus 2. So that's actually the best factorised answer, but this is pretty good. Expanding a double bracket, so do the first. 2x times 4x is 8x squared. I know sometimes people forget to do the square there. Then the outer one, so 2x times 3, sorry, that's 6x. And then the inner minus 4x. And then the last two, minus 1 times 3 is minus 3. Be careful with your signs. Obviously there's a danger of forgetting to put the right signs in the right place, and then we must simplify this to get 8x squared. 6x minus 4x is 2x, and then minus 3. Solve this equation. This is a grade C equation. There's brackets and there's x's on both sides, so we multiply out this to get 5x plus 20 equals 3x minus 25. Take away 3x from both sides gives us 2x plus 20 equals minus 25. Take away the 20 gives us 2x. This is very bad form going across the page, should really be going down the page to do equations. 2x equals minus 45, and therefore x equals minus 22.5, because it's half of 45. Solving this question, this is a quadratic equation. When it says solve to one decimal place, that's your clue to use the quadratic formula. Minus b plus or minus b square root of b squared minus 4ac all over 2a. So this is our a, this is our b, this is our c. So a, b, c. A equals 2, b equals 6, c equals minus 5. It's worth writing out the numbers in the equation. So we've got minus 6 minus b plus or minus the square root of b squared. I would just do that. If I can do it straight off, I would just do 6 squared is 36, minus 4 lots of a, 4 times 2 times negative 5, all over 2 times 2, because 2a. Now Be careful with these negatives. Be careful when you're squaring this b squared. B squared is always a positive value. And when you type it into a calculator, if you were using the calculator, you need to be careful. If it's a negative b, then you need to square the negative value in a bracket. So let's type that in, minus 6. Tend to use this symbol for the minus rather than the takeaway. And we're going to use the plus first. There's two solutions, one will be plus, one will be the minus. We're going to do plus first and then change it afterwards. In fact, I've got to just remembered to do the fraction first because we need to put the fraction on the bottom. So minus 6 plus the square root of 36 minus 4 times 2 times negative 5 all over 2 times 2, which is 4. And that should give us the answer. We're asked to one decimal place, so that's 0.67, so that's 0.7. And the other solution is nice and easy. We just need to go back into this equation and change that plus to a minus there, because that's the second solution with the minus. Work that out, and then that's minus 3.6 or 3.7 to one decimal place. Question 17. Write down the first four terms of the sequence 5 minus x squared. So all we're doing there, I suppose that should really be an m, but 5 minus x squared, we're just making x equal to 1, 2, 3 and 4. So we've got 5 minus 1 squared, 5 minus 2 squared, 5 minus 3 squared, and 5 minus 4 squared. 5 minus 1 squared, 5 take away 1 is 4, 5 take away 4 is 1, 5 take away 9 is minus 4, and 5 take away 16 is going to be minus 11. So those are the first four terms. Work out the nth term of this sequence. Let's just quickly see what sort of sequence this is. It's going up by 4, then 6, then 8, then 10. So the second difference is 2. That tells us it's based on a quadratic, and just a straightforward quadratic, so it's based on 1, 4, 9, 16, 25. It's based on the square numbers. And the sequence is 20, 24, 30, 38 and 48. So what are we doing to these square numbers to get to these? Well, let's just work that out as a separate sequence. We're adding 19, and then we're adding 20, and then we're adding 21, 22 and 23. So that sequence there is going up by 1 each time. So that's based just on n. And what we're doing to n, well, if n's 1 in the first one, we need to add 18 to it. So the second number is 20, so n, when it's 2, is 2 plus 18 is 20, then 3 plus 18 is 21, 4 plus 18 is 22, and so on. So we've got the n squared plus n plus 18. So the answer to that is n squared plus n plus 18. Okay, missing coordinate of the parallelogram. Now, originally when I made this question up, I originally intended it just to be the one position, but when I thought about it, it's actually got quite a few positions. So 3, 1, 8, 1, that's on a horizontal line. 6, 4 is going to be up here somewhere. Okay, so we could have, let's just put a few positions, possible positions. We could have this one here, where that makes the parallelogram. We could have it coming this way to be over here to make the parallelogram, and we could even have one down here, which would be unusual to find. So to make these positions, all you've got to really do is to do this one. This side has got to be parallel to this side, so those two sides will be parallel, and therefore this is going across 2 and up 3. So these two need to go across 2 and up 3. So going across 2 this way takes it back to 1, and then 3 up is 4. So 1, 4 would work. If it was going up this way, that makes it parallel to this side. Let's do a different colour. It would be this. These two sides are parallel. So how far across and up is it going now? Well, it's still going up 3, but it's going across 3 and then up 3, across 3 and then up 3. So it's going across 3 from 8, which would be 11. And up 3 would be 4 still. And this one down here, let's just use black for that one. If these two were parallel, then we need to realise that we're going across 2, down 3, so we need to go across 2 and down 3, which would be 5, and down 3 from 1 would be minus 2. So there is 3 possible answers. I would have thought one of these two would be the most common. Simplifying a rational expression. I mean, this top part of this is a quadratic. It's screaming out to be factorised, so let's factorise it. So x squared, we've got an x, it's going to multiply to give us 4, so it could be 4 times 1, only really 4 times 1 will work there, or 2 times 2 I suppose. And it's got to add to give us 5, so 4 plus 1 adds to give 5, so it's going to be plus 4 at plus 1, or it could be plus 1 plus 4. This bottom bit doesn't look like it's going to go with those, but if we see there's 3 in both of these, we can factorise out the 3 to get 3 lots of x plus 1, and clearly we've got an x plus 1 that cancels there to give us x plus 4 over 3. Okay, moving into the pure geometry section now. So question 21, the perimeter of a sector is a part of a circle, so there's a whole circle. If I've got part of a circle from the centre, like a pi of a circle that's got 100 degrees, we're trying to find the length of these sides added together because we want the perimeter. So we're actually looking at a slice of pi that is 100 degrees this way. This is 5, this is 5. We need to work out this length and add it to the two 5s. Quite often a common mistake is just to work out that arc length and leave the 5s out, but we want the perimeter of the whole sector. So, perimeter of a sector, what is the perimeter of a whole circle? Well, that's pi times the diameter. That's the circumference of the circle. We only want this fraction of the whole circle, which is 100 out of the whole circle, which is 360. So we want 100 out of 360 times the pi times the diameter. The radius is 5, so we want 100 over 360 times by pi times by 10. The diameter is 10, and that's going to give us, let's get the calculator out. That's going to give us 100 over 360 times by pi. Now we could leave this. We could leave this in terms of pi. It does actually say on the question that it wants it in 1 decimal place. That was a bit of a mistake. I should have really left it as a question in terms of pi. So the arc length there is 25/9 pi. So we just need to add 10 to that, so we've got that plus 10, and that gives us 18.7 to 1 decimal place. But you could have left it as 25/9 pi plus 10. That would have been okay if it didn't ask it to put a 1 decimal place. Okay, question 22, right angle triangle. It doesn't actually have the right angle, but it's clearly a right angle. Should have a right angle written in there. We've got an angle, we've got a side, we want to find PQ, we want to find this side, we'll call that X. Okay, so that's in a right angle triangle with an angle. It's got to be trigonometry. This is the hypotenuse, this is the opposite side, this is the adjacent side. Our formulas for trigonometry are sine, opposite, hypotenuse, so, ka, to, a. So which one do we want to use? We are not using the adjacent side, so we're not going to use this formula, and we're not going to use this formula because they have adjacent sides in it. So we're going to use the sine formula. Thinking about a formula triangle, where we have the opposite, opposite over sine times hypotenuse. If we want to find the hypotenuse and call that x, we want to find that, so we just rub that a little bit out. That just leaves us with opposite over the sine of 28. So the hypotenuse x is equal to the opposite over sine 28. And the opposite side is 60, so let's just put that in there. So that's the answer. Now you could, if you're not familiar with the formula triangle thing, but you know sine of the angle, sine of 28 equals the opposite, which is 60, over the hypotenuse, which is x. You've got to be careful here because x is on the bottom. Essentially you need to times by x to get x sine 28 equals 60, and then divide by sine 28 to put that onto the bottom to get x equals 60 over sine 28. So that's where that comes from. It's much easier if you use the formula triangle, but you don't really need to do that. So let's just divide by sine 28 and we get 127.8 to 1 decimal place, or 128. if you would do it 3 student figures. Okay, a circle theorem question. This is the alternate sector theorem. So this line here is a tangent to the circle. This angle here formed on this, between the tangent and this chord. The angle formed in the alternate segment, this one, this angle's formed from this chord. Those two angles are the same, so that angle there is also 70, and that helps us do it because now we've got a triangle 70/40A, and that adds up to 180. So A is just going to be 110, from 180 is 70. Or you could do it on this angle here, because this angle forms this angle 40. This is, you could work that as 40, and then we've got the angles on a straight line, which would be the same thing. Okay, last two questions. Question 24 is just any old triangle with an angle we're trying to find. We've got 3 sides. This sort of question is either going to be cosine rule or sine rule. Because there's 3 sides involved, it's the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos the angle A. Now that's in a triangle where the angle, if this was angle A, then this would be little a, this is angle B, this would be little b, and this is angle C, this would be little c. Now that's given to you as part of your formula book beginning of the exam. So all I really need to do is ignore that B and change that to an A, and I've just bung the numbers into this formula where this is little a. These can be any order, B or C, because it doesn't matter. So a squared is going to be 80, b squared is going to be 80 squared, 75 squared, c squared is going to be 95 squared, minus 2 times 75 times 95 times the cos of A. Now, let's just work a little bit of that out. Let's get the calculator in. 80 squared. Now, a very common mistake here is to, in this part of the number here, to think of that as just being a separate number and it's not times by cos A, just maybe plus cos A or something, and then take that away or add it to the rest of the stuff, but you can't do that. 75 squared is certainly a number that we can add to 95 squared, that's okay, and we get 14650, but we're taking away this whole thing, which is 2 times 75 times 95 times the cos of A, so it's 14250 times the cos of A. Now we can't take that away from that because we've got to times by cos A first. So what you can do is take this over to this side, so take that over there by taking it away, so we end up with 6400 minus 14650, which is going to be a negative number, minus 8250, and that would be equal to minus 14250 cos A, and then we need to divide by minus 14250 to get rid of it on this side, and then put it on this side. If you imagine this being just 5 times cos A, or 5A even, to get rid of the number in front of the cos A you need to divide by it. So we need to divide by negative 14250, and that gives us 11 over 19, so cos of A is 11 over 19. To find A, which is an angle, we always use the inverse of the trig function to find the angle. Bung the answer in there. So cos of the minus 1 of that is going to give us an angle of 54.6 degrees, or 55 degrees to the nearest degree. Okay, last question. Unfortunately I didn't draw a diagram for this, which I think confused some people when I gave it to them to do. So if you just put O, A and B anywhere, doesn't really matter. A is going to be the vector that goes from O to A, B is the vector that goes from O to B, AB is the line between A and B, AM and B is in the ratio 3 to 2, so if I've got a point M along that line where this is 3 and this is 2, and I want to find OM, oops, missed. I want to find O to M, I want to find that in terms of A and B, well, I need to go along the lines I've drawn, not this OM line. So first of all, I need to work out what fraction of AB do I need. So I want to go from A to B. In fact, let's write the whole thing out properly. So OM is going to be, I'm going to have to go around the outside from O to A, which is OA, and then from A to M, which is A plus AM. OA is nice and simple, that's just the vector A. A to M is going to be 3/5, this is 3/5 of the line, this is 2/5 of the line. A to M is 3/5 of this whole line, which is AB. Now AB, I'll do it separately, is going from A to B. I can only use A and B, so I've got to go down this line and across here. Going down this line is the opposite way of A, which is minus A, and then along this line would be plus B. Now that could be written as B minus A. It's a bit neater to write as B minus A. So I want 3/5 of that. So I've got A plus 3/5 of, I'm going to put minus A plus B. So I've got A, I'm going to multiply this out. So I've got 3/5 times minus A, which is minus 3/5 A. And 3/5 times B is plus 3/5 B. And A, take away 3/5 of A, it's going to leave me with 2/5 of A. So that's 2/5 of A, and I've got plus 3/5 of B, and there's my answer.